Hello and good morning. Thank you for tuning in to the first and last episode of The Breedlove Show. I'm your host, Sean Breedlove. Our main story today is going to be on the neurochemistry of reproductive behavior. To start, I'd like to talk about gray wolves, which are monogamous animals. That is, they find a mate and stay together for life. In contrast, spotted hyenas are known to be promiscuous and mate with different partners throughout their life. Today, I'd like to answer two questions. Why is their sexual behavior so different? And do we know what can explain these differences in mating behavior? To do this, let's look at the vole, a close relative of the hamster. I know it looks more like a rat, but it's closer to a hamster. Different species of vole have very different reproductive behaviors. For example, both male and female prairie voles practice strong monogamous behavior, while the male and female meadow voles practice more promiscuous behavior. And no, they don't actually dress like that, but it'd be really cool if they did. Because of these very different reproductive behaviors across closely related species, voles have been the subject of much of the research into which chemicals in your brain control different reproductive behaviors. These chemicals have been found to be oxytocin and vasopressin. Both of these chemicals are created in the hypothalamus, shown here in red. According to the results of these studies, the female prairie vole brain releases a large amount of oxytocin during sex, and the male prairie vole brain releases a large amount of vasopressin during sex. While the male meadow vole brain does not release vasopressin, and the female meadow vole brain does not release oxytocin during sex. The female meadow vole doesn't release oxytocin until she's giving birth, and that's because oxytocin helps contractions. Other studies have shown that when drugs are used to block vasopressin in prairie voles, the male prairie vole becomes more like the male meadow vole, that is, they engage promiscuous behavior. And when oxytocin was blocked in female prairie voles, they become more like female meadow voles, that is, they do not form strong attachments to their partners. Because of these findings, scientists are almost certain that oxytocin and vasopressin are responsible for the reproductive behaviors of voles. But what about humans? Humans are more complicated, probably because we have much more complicated social interactions. For example, when you have a crush on someone, the oxytocin levels in your body are pretty much normal. That's because the feelings that you get when you have a crush, like the sweaty palms and the sped up heart rate, that's controlled by norepinephrine. And that really good feeling you get when you're around your crush, that's controlled by dopamine. When you actually start to form a relationship with someone, though, your brain releases oxytocin and vasopressin, which creates that bond between the two of you. That is why, on average, people in a new relationship have much higher oxytocin and vasopressin levels than someone who's single. Interestingly, though, the length of their commitment doesn't really cause more oxytocin or vasopressin to be produced by the brain. The only thing that causes that is when the relationship is more intimate. But because most of the studies done on humans are correlational, I have to show you this. So, yes, we can say why vole sexual behavior is different, and we know which chemicals cause those differences. But no, we cannot say that for humans. Hopefully one day we can. That's the show. Thanks.